Well, greetings. Hello, my lovelies. Welcome to another fun-filled lesson dealing with radicals. Radical expressions is next up on the agenda, and it'll combine everything you've done so far with adding and subtracting and multiplying radicals, dividing radicals, and that oh so important task of rationalizing the denominator, because we never like rational terms. That is, a term with a radical, a square root, or a cube root. We never like to see those in the bottom of a fraction for some really good reasons, which you'll begin to appreciate when you do Calculus Math 31 later on. So here we go. This is page 126 of our workbook, and as usual, it begins with a bit of a warm-up and a bit of a review. All right, so let's move this over there, and let's get started. Simplify the following radical expressions. State any restrictions on the variables. All right, so here's an example where we have a radical term plus a number, so something, a radical plus or minus a number. And remember that the strategy here is to multiply by the conjugate, okay? And the conjugate of root 2 plus 3 is simply root 2 minus 3, all right? So that's what we have to multiply the bottom by to rationalize, to get rid of that, that square root of 2. But we just can't multiply by any number we pull out of our hat. We have to always multiply by something that eventually equates to 1. So if you've got a fraction of root 2 minus 3 on the bottom, that's going to turn to a fraction of root 2 minus 3 over root 2 minus 3. Because this whole mess, anything divided by itself, which is what we have here, is 1. So really what we're doing is multiplying what we began with by a value of 1, just written this way. And it's written this way so that we can get rid of the square root of 2. So when we do this mess, what are we going to get? Well, let's do the top first. You have 1 times root 2 minus 3 on the top, and on the bottom you have root 2 plus 3 times root 2 minus 3. Easy as that. Top is easy because 1 times anything is simply going to be that, okay? And the bottom, because you're multiplying by the conjugate, normally when you multiply binomials by each other, there are 4 multiplications. We can simplify into 2 products or 2 partial products. Because you're multiplying by the conjugate, the 3 times root 2 will subtract out from the negative 3 times root 2. So all we're really worried about is the root 2 squared, this times this, and the minus 3 squared. There. Now, this is an entirely optional step. The more you do this, the more used you are, you will become to actually skipping that step altogether. And you could easily go straight to asking yourself, well, what is the square root of 2 squared? Well, that's just 2. And square root of 3, of course, is 9. And we're going to get root 2 minus 3 over, what is that, negative 7? Okay. Now, when you've got it like this, there's one more step you can take, and I think we're going to actually require you to do that. And so what we're going to do is we're going to multiply this whole mess by negative 1. Okay? Remember that when you multiply an expression by 1 or negative 1, you change how it looks a little bit. Well, when you multiply by negative 1, you'll change how it looks, but you're not going to change the value of the answer or the overall expression when you start plugging in values for x and y. But what multiplying by negative 1 is going to do for you? Well, it's going to get rid of the negative 7 on the bottom there, and that's really what we want. All right? So we're going to have negative 1 times root 2. We're going to have negative root 2. Negative 1 times negative 3 is going to be plus 3. And the negative 1 times negative 7 is going to be plus 7. See how we got rid of the negative 7 here? And you're going to say, well, so what? Well, it gets rid of the negative 7, and when you rearrange the topinator, the numerator of the fraction, instead of negative root 2 plus 3, you can rewrite that as 3 minus root 2 over 7. And that just looks a lot more elegant as a final answer. Restrictions? There aren't any because there are no variables in that first expression. So boom, you are done. Let's move on. All right. So here we now have a variable in the inside the rational of the denominator. You know what the plan here is, and that is to multiply by its multiply by a fraction that equates to 1, but which has root 6 in it. Okay. Now there's two ways to do this, and I'm going to do it probably the least elegant way right now. I'm going to multiply by root 6 over root 6, and we're going to see where that gets us. Because, whoops, root 6x. Sorry, root 6x times root 6x. Because when I go through this, here's what's going to happen. Root 2 times root 6x is going to be root 12x. The simple rules of multiplying radicals, as long as the index is the same of the two, then you just, and they are, because these are both square roots, so the number hidden right there and right there are both 2, then you just multiply the radicands by each other. And then root 6x times root 6x is simply 6x, just like that. Cool? All right, and so can we simplify this at all? Sure we can, because inside that square root of 12, there's a perfect square hiding. You see it? It's 4, right? So when I take a 4 out of the square root, I'm going to have 2, and then 3 times 4, which is what the 2 would be when it was inside the radical, would be the 12. That's good. And x, just like that, all over 6x. And then now I can, because these coefficients are outside of the radical here, I can simplify that to simply 3x over root 3x over 3x. And boom. Good. Now, there's another way to do it, and it yields the exact same answer. Let's try that one now, okay? If we go ahead and do the divisions, first of all, we can do that. And remember, when you're dividing radicals by each other, and as long as the index is the same, then it's just, well, root 2 over root 6x will simply be 2 over 6, or 1/3. And so you'll go directly into an expression that looks like this. Okay? So look what I've done. 2 divided by 6 is 1/3. 2 over 6 is 1 over 3. There's the 1 and there's the 3. And then the x stays in. Now the problem, of course, is that we have a radical in the denominator, so we're going to have to multiply it by root 3x. Just to get rid of it, we're going to have to rationalize it by doing that. And that's going to yield, well, 1 times root 3x is simply going to be root 3x. And root 3x times root 3x is going to be 3x on the bottom. And look, we get the exact same answer, right? Two different ways of doing it, but we always yield the same answer. And that's kind of elegant because it proves to you that no matter what you do, as long as you've got the steps correct, the math works out and you'll get the same answer, the same result. One thing we're missing now, because we have the x, we have a variable, we have to think about restrictions on what x can be. Okay, so we have to look both to the initial expression and to the final expression, right? So in the initial expression here, you have x inside inside the radicand. Could x be negative there? Well, if x were negative here, then you'd have the square root of a negative number, and that won't work. Could x be 0 here? And the answer is, yep, x could be equal to 0 here because 6 times 0 is, well, 0. And you can take the square root of 0, which gives you 0. But if this whole mess, if the whole denominator is equal to 0, then your expression blows up because it becomes an indeterminate form. So you would think possibly that x could be greater than or equal to 0, but you have to look at it in the big picture. Remember that any number over 0 is indeterminate. So x must be greater than 0 in order to avoid that indeterminate form. Boom, we're done. Let's go on to some real-world problems of dealing with expressions now. Just like you had linear expressions where you solve for x, or you solve for y, or you solve for both, we can do the same thing here, and that's what we're going to do on the next page. Moving right along, let's go to page 127 and see what we got to work with here. Solve the following equations. State any restrictions. And we're going to do one more step here, and that is we're going to verify our solution. So we're going to do basically 3 columns worth of work here, and we'll do it something like this. Well, first thing I'm going to do is move the 4 over, so I get square root of x plus 3 is going to be equal to 3. There is a value for x that makes this all work out, and that's what we have to determine, okay? Well, I got the square root of x plus 3, but what I want is x, not the square root of x. So what if I square both sides, okay? And if I square both sides, I'm going to get the square root of x plus 3 squared, and that's going to leave me with x plus 3 on the left side and 9 on the right side. And when I move the 3 over, I'm going to get x equals 6. So it seems like the answer that will satisfy this, the value for x that will make this whole equation true, is x equals 6. So now we should prove it and make sure. So I'm going to put a little divider here. And the first thing I'm going to do is I'm going to look at restrictions. And it may seem a little weird here to look at restrictions, but at least it tells us whether our answer is in the ballpark. So what is the restriction? Well, the restriction is that the value inside the radical sign, the radicand, x plus 3, must be greater than or equal to 0. Can't be negative. So we know that, well, actually I'm going to just write this in here as restriction, because that's what we're doing. Okay, x plus 3 must be greater than or equal to 0. In other words, x must be greater than or equal to negative 3. Is it? Is x greater than or equal to? It is. So that tells us that this is a reasonable answer compared to what our restrictions are. Cool. All right, so let's do one more step. We think we have the right answer. It certainly meets our definition of the restriction. Let's just verify. Now what we're going to do is we're going to verify x equals 6, and we're going to compare the left side of the equation with the right side of the equation. Okay, so what we're going to have is square root of 6 plus 3. What we're doing is substituting x equals 6 wherever you see x over here. So this first x is going to turn to a 6. Square root of 6 plus 3 plus 4 equals 7. In other words, the square root of 9 plus 4, well, you know what, here, let's even save a step, should equal 3 if this all works out, if it's true. And in fact, it is yes, good, we're good to go. But the answer is x equals 6. The restriction on it doesn't matter because we got a number that's greater than. But you can imagine a situation where you might have two possible answers, and this restriction will tell you which one of those two, if one is not allowed, which one of those two is the correct one. And I actually think we run into a question like that later on in the examples here. All right, good to go. Let us do the next one. So where do we start? Well, you see the numbers here and the numbers here. It's always a good idea to move the numbers over. So the first thing I'm going to do is move the 8 over. And I'm going to get the square root of 3y over 5 is going to be equal to what? Positive 6 now. Yep. And so what I can do, same thing as I did on that first question here, is square both sides. Because squaring both sides is going to get rid of that the square root sign, because the square root, the square of the square root of anything is just going to be that anything. So we're going to square both sides. And when we do that, we're going to get we're going to get 3y over 5 equals, whoops, not 6, but 36. And when I multiply now both sides by 5 to clear the fraction here, clear the denominator, I'm going to get 3y equals, well, 3.5 to 360 is 180. And when I further finish this off, I'm going to get y equals to 60. All right. So we think y is going to be equal to 60 here. We're going to check it against our restrictions, and then we're going to verify, and then we're going to see if we're correct. Hint, we are correct. Okay, so let's look at restrictions. Well, what we're looking for is the radicand being greater than or equal to 0. So not the square root of this, but 3y over 5 must be greater than or equal to 0. And if I multiply both sides by 5, I really got what? 3y greater than or equal to 0, because 3y, I'm multiplying both sides by the same number, the same value, doesn't change the equality or the inequality. And then 3y is going to be greater than or equal to 0. In other words, y must be greater than or equal to 0. So any value of y that's greater than or equal to 0 could be a solution. We think 60 is a solution, it's greater than 0. So far we're good to go. Our answer jives with the restriction. So now I'm going to verify. And I'm going to verify similar to this, but I'm just going to look at the left-hand side here, okay? Because I know that the left-hand side has to equal to -2. So what I'm going to do is substitute 60 for y and see if it equals the right-hand side. All right, so what do I get? I'm going to get -8 plus 3 times 60 over 5. Okay? In other words, -8 plus the square root of, what is that, 3 times 60 is 180? Good. Well, this all turns out to be -8 plus the square root of 36. Cool. And what is this going to be equal to? Well, this is going to be -8 plus 6, which equals to -2. And there's the right-hand side of the equation. So we've done the verification here. It works. We're good to go. So it gets a little bit trickier as we move on, but that's the general state of affairs. Here we only have one example or one value to test to verify against. In some cases, we could have more than one. We could have, say, a quadratic built in there, and then we also all of a sudden we have to test both of the quadratic roots to see if they satisfy the equation. Oh my Lord, we have a bit of a quadratic going on here. Question C. All right. All right. First step is to get rid of the radical sign, and I can get rid of the radical sign by squaring both sides. Okay. When I square the square root of x squared minus 4, I'm just going to get x squared minus 4, right? So I'm going to square that. And on the right side, the square of 6 is going to be 36. So take a moment there and make sure you understand what I've just done. I'm squaring both sides. That doesn't change the equality. It doesn't change the value of the expression. It doesn't change any of the answers you're going to get. When I square both sides, I'm going to get rid of the radical over there. So now I'm dealing with x squared minus 4 as opposed to square root of x squared minus 4. But if I square the left side, I have to square the right side. So the left side squared is just x squared minus 4. The right side squared is whatever 6 squared is, which is 36. All right? So what do I got now? Let me bring the 4 over. I'm going to get x squared equals what? 40, yeah? Okay. And then to get rid, I know what x squared is. I want to know what x is. So what I'm going to do is I'm going to take the square root. Whoops. That it does not spell square root. So let me try to spell square root the way I would normally. It's the root. I'm going to take the square root of both sides. And when I do that, I'm going to get plus or minus the square root of x squared equals the square root of 4. Remember the square root rule where if you take the square root of something, you could have had possibly a positive or a negative value that when you squared gets rid of the value. All right. And so what this means is that x is going to be equal to plus or minus, x is going to be equal to plus or minus the square root of 40. And if you're asking yourself that square root of 40, can it be simplified? It absolutely can. X is going to be actually equal to plus or minus, well, what's the square root? What's the perfect square that's hidden inside of 40? Do you see it? It's 4. And the square root of 4 is 2. So square root of 40 is the same as 2 root 10. And if you don't believe me, just do that calculation. Take the square root of 40, and then take the square root of 10 and multiply it by 2. You'll get the same answer, the same value. So there's your answer. Now we're going to look at both restrictions, and then we're going to verify. All right. So restrictions. Well, it's the same story. Whenever you have a value or parts of the expression inside the radical, it's that radicand has to be greater than or equal to 0. So for restrictions, x squared minus 4 has to be greater than or equal to 0. In other words, now, well, x squared has to be greater than or equal to 4. And if I take the square root of both sides, then I get plus or minus the square root of x squared is greater than or equal to 2. In other words, plus or minus x is greater than or equal to 2, right? Plus or minus x squared, yes, because the square root of x squared is just x, but it's plus or minus x. So plus or minus x has to be greater than or equal to 2. In other words, x must be greater than or equal to 2, or negative x has to be greater than or equal to 2. All right? Let's verify this solution. And to verify, we're going to take both the plus or minus, right? There's two possible answers here, plus or minus 2, if you take a look up here. Okay, so we're going to take both of those possibilities and we're going to fit it into, or plus or minus 2 root 10. These are both of these numbers. We're going to plug back into the original, and we're going to verify and make sure that the left hand is equal to 6. So we're just going to look at the left-hand side, and we're going to verify that the left side equals 6. That's what we're going to do. Okay, how do we do that? There's left side. Well, let's do it this way. We want the square root of plus or minus 2 root 10 squared. Remember, we're taking this value here and we're plugging it into here. Minus 4. Okay, so we're going to see what this equals, and hopefully this is going to equal to 6. That's what we're hoping for. All right. Well, it doesn't matter whether 2 root 10 is positive or negative. When you square it, you're going to get rid of the negative value. So what we're going to have is the square root of, well, 2 squared is going to be 4. Root 10 squared is going to be 10. And all of that under the radical sign. So 4 times 10 minus 4 is what you're left with. Well, that turns out to be 40 minus 4, which is square root of 36. And the square root of 36 equals 6. That's the number we wanted here to verify, to make sure that we have the correct answer. And so it is verified. Boom. Cool. All right. So in the first 2 examples, we only had to verify one number, one value, because there's only one value for x or y, for the variable. In the third example, we had to verify for 2 possible values, but it turned out that those 2 possible values are really only one value because of the expression, because you're squaring them, it got rid of the negative value, so it's good. So the last question on this page is going to test for, we're going to come up with 2 different numbers, and you're going to have to verify both of them, so it's a little bit more work here, all right? What we're going to do is bring the 6 over, and bring the root 2x plus 3 to the other side. Because when I move the negative root of 2x plus 3 to the other side, it's going to turn it into a positive, right? Boom, like that. And then what I'm going to do is, to get rid of this radical sign, is I'm going to square both sides. Okay? What's that going to do for me? Well, on the right side, it's going to get rid of the radical. I'm going to be left with 2x plus 3, which is great. But on the left side, what I'm going to have, when I square x minus 6 quantity, I'm going to get x squared minus 12x plus 36, which is going to be equal to 2x plus 3 over here. You see what we're setting ourselves up for? We're going to have a quadratic here that we have to solve for. We're going to get two possible roots, and so we're going to have to test and verify both of those roots in here. Hopefully, we don't have to use quadratic formula. Hopefully, we're being nice and not mean to you. Maybe we'll save that for Math 30-1 next year. All right, when I fix this up, I'm going to have x squared minus 14x, because I'm going to bring the 2x over there, plus 33 now equals to 0. And I'm not going to delve too much into this, but 2 numbers that multiply to 33 but add to 14, well, it's going to be, x minus 11 times x minus 3 equals 0, right? This kind of thing has to be more automatic for you, all right? And if you have to do the cross here and 2 numbers that multiply to 33, add to negative 14, well, 11 and negative 11, negative 3 do that for you, right? So do what you need to do, but we come up with this, and we come up with 2 values now for x. X can be either equal to 3 or to 11. And now that you see 2 possible answers here, like this one, but unlike the 2 on the top, we will have to test and verify for both. So to start, let's work on our restrictions. All right. Well, the restriction is pretty easy. Again, you're just looking at the radicand here and ensuring that it is not negative. In other words, 2x plus 3 must be greater than or equal to 0. In other words, 2x has to be greater than or equal to 3. X has to be greater than 3, negative 3, negative 3 halves. As long as x is greater than negative 3 halves, then you know you're going to have a valid answer. That doesn't mean that the answer is negative 3/2. It doesn't mean that there's more than one answer. It just means that when you get your answer, and in fact we do here, that both of these have to satisfy this. And in fact they do. So both of these answers could be correct. Yeah. Let's see which one of those answers, or if both, are correct. And we do that now by verifying. And we're going to, well, if you look at the original expression here, we've got a whole mess on the left side equals to 6. So what we want to verify is left side equals to 6. And if it does, then that'll give us a proper answer, or that answer will be considered to be correct. All right? We've got to do it 2 times now. So let's start with, let's verify x equals 3. Okay? When I have x equals 3, then I've got 3 minus the square root of 2 times 3 plus 3. See what I'm doing there? I'm just substituting x equals 3 in here. So 2 times 3 plus 3. Good. In other words, I'm going to have 3 minus the square root of 6 plus 3 is 9. In other words, I'm going to have 3 minus 3, which equals to 0. Does 0 equal 6? It doesn't, which means that x equals 3 is not a solution. All right, so there we have 2 possible solutions from factoring this quadratic and checking these out. Both fit the restrictions, but x equals 3 doesn't work, doesn't actually solve the specific equation. Right? So let's now try. Let's put x equals 11, and let's see if that verifies. Hopefully it does. Hopefully we get at least one correct answer out of this, right? All right, so when x equals 11, I'm going to get x minus 2 times 11 minus 3, I believe. Nope, plus 3. Good. And so that's going to be, oh, and I should have put, I'm substituting 11 in for every instance of x. So there's an x here and x here. So it should be 11 minus 2 times 11 plus 3. Cool. Which is 11 minus, well, 22 plus 3 is 25. And the square root of 25 is 5, of course. We're going to get 11 minus 5 equals 6. That's the left side. Does the left side equal 6? Yes, it does. So our solution then is the set that includes the number 6. 6 is the only solution we have there. So I'll leave that with you. Take a look at that before we move on to the next question. Make sure it all makes sense. Go step by step. And then we'll move on to page 128. Here, let's get to her. These are tricky, as word problems and all these extra questions always are. It's using the information you know to solve the question. This is what always gets kids tripped up when they do tests and stuff. Because I've never seen a question like this before. How do I solve it? Well, the more of these we do, then the more used you get to being able to solve these. And so, you know, it is what it is. Write and solve a radical equation to find a positive real number that exceeds its square by 6. We're looking for an expression that equals another side, not an expression that is greater than or less than. So we're looking for an equality. So let's let x equal the positive real number. Okay, we're going to let x equal that positive real number. Write and solve a radical expression to find a positive real number, some value of x, that is equal to the square root of x plus 6. Take a look at that. a radical equation, we got it, okay, to find a positive real number that is equal to the square root of itself plus 6. Now, when you look at the equation, I think you can find meaning in it, and you can see how this relates to the question. The problem and the sticky point, and the thing for which I have no easy answer for you, is how do you go from the words to the equation? There is no easy answer. You become more comfortable with it the more you do. All right? That's all I can say. So presuming that this makes sense to you, and if it doesn't, you really need to pause here and read the words and try to read for meaning and make sure you can figure out what's going on there. X is a real number. It's a real positive number. X equals, there is some value, there is some number out there for which equals the square root of itself plus 6. And that's what we're going to figure out. All right? So first thing I'm going to do here is I'm going to bring the 6 over. So I'm going to have x minus 6 equals the square root of x. Cool. Then I will, because I want to get rid of the radical, I'm going to square both sides. Square BS. BS stands for both sides. And when I square both sides, I'm going to get something that looks like that, right? So on the right side, the square root of x squared is going to be x. I'm going to end up with x on the right side. On the left side, I'm just going to expand this little binomial here, and I'm going to get x squared minus, 12x plus 36. And on the right side, I'm going to get x. And I think you might see where we're going here. We're going to end up with a quadratic, where we already have a quadratic, but we're going to end up with, hopefully, a factorable quadratic that has 2 roots and therefore 2 values of x. And then we're going to test both of those values, both against the restrictions that we establish, which are pretty obvious, right? If x is inside the radical, x has to be greater than or equal to 0. But it already is because of the question. So we're not going to have to do a restriction test, but we're going to plug those values for x that come out of the quadratic equation and test them to make sure left side equals right side and make sure that everything is copacetic. So when I finish and I simplify this, I'm going to have x squared minus 11x plus 36 equals 0. There's a quadratic. There is the quadratic for which we need to find the roots. And so at this point in your careers, because we've worked so much on quadratics, you should be able to look at that and fairly easily determine that the roots have something to do with 9 and 4, like that. Because x minus 9 times x minus 4 is going to be equal to 0. What is x? X is 4 and 9, just like that. All right? So we have 2 suspected answers for a value, for a number, for a real positive number, which exceeds its square root by 6. Let's test and see which one, or if both, work. At least one, we hope, will work when you verify. So let's verify. I'm going to move this over here a little bit. Okay. So let's verify x equals 9. All right. And to verify x equals 9, we're going to substitute 9 in for every location where you see x in the x equals square root of x plus 6. All right. So rearranging here. Good. So what will I get? I'm going to get square root of 9 plus 6 equals, and then x on the other side is going to be straight up 9. Okay? We're going to see if that works. Does this equal that? Well, the square root of 9 is 3. 3 plus 6 is there. Yes. So x equals 9 seems to be a working solution for us. Great. Let's test x equals 4. All right. And so when we test x equals 4, we're going to get the square root of x, which is square root of 4, plus 6 equals 9. That's the equality that we want to test for. Well, square root of 4 is 2. 2 plus 6 equals 9. Nope. Check testa. Nope, doesn't work. All right. So x equals 4 is not a number which equals the square root of itself plus 6. And so we say the solution is simply 9. Boom. We're done. That was actually fairly easy. Actually, not so much work there. Not so much trouble. The next question, though, this one here, is going to take a little bit of work. So I would suggest you grab yourself a clean sheet of loose leaf, because this is going to take a lot of work here. All right. You can fit it into the space you have right there, but it's going to be really messy. So I suggest you pause this video, go get yourself a sheet of loose leaf, and I'm going to solve it straight up down on here. And I'm going to start with the overall expression, which was 4x plus 5 minus square root of 2x minus 1 equals 2. Okay. All right, so where do we start? What I'm going to suggest is that you isolate one of the radicals, and then let's see where that takes us. Does it matter which one you isolate? No, it really doesn't. But you're going to isolate one. So 4x plus 5, square root of 4x plus 5 comes up first. So I'm going to isolate it. So I'm going to work with square root of 4x plus 5. And I'm going to toss everything else to the other side there. So this is going to equal to 2 plus square root of 2x minus 1. Okay? So as I said, you can do it either way. You could go the other way. You could isolate the 2x minus 1 and go and work with 2x minus 1. Square root of 2x minus 1 is going to be equal to the square root of 4x plus 5, okay, minus 2. Now I know you can't see that, so I'm going to move this a little bit. So either one of these approaches will work. I've chosen to do this one here because I've got all positive numbers and positive values here. But when we're done this, and if you understood what we're going to do down here just with this, go back and do it with this and see if you don't get the same solution and the same answers. Okay, that'll test your algebraic skills and give it a good run for their money. Okay. All right. So here we are. We've isolated square root of 4x plus 5. Well, the key here is always to get rid of the radical signs. And we get rid of the radical signs by squaring both sides. Okay? And when I square both sides, I'm going to get, well, the square root of 4x plus 5 squared is going to equal to 2 plus the square root of 2x minus 1 quantity squared. Okay, so I'm just going to square both sides, because what that's going to do for me is it's going to eliminate the radical here. I'm going to get 4x plus 5 on the left side, and on the right side I've just got a polynomial to work with, which is not hard at all, actually. Pretty easy. So to resolve this polynomial, first inner, outer, last, FOIL, or first outer, inner, last. I don't know. I don't use FOIL. Maybe you do. Maybe your tutor does. I don't. But I can look in this and by inspection, I know I'm going to multiply 2. I'm going to square 2. Whoops. Because I'm squaring it, right? So I'm going to square 2. I'm going to get 4. And then I'm going to get 2 of the square root of 2x minus 1 and another 2 of the square root of 2x minus 1. It's going to give me 4 of the 2x minus 1. And then finally, I'm going to square the last terms here, And I'm going to get, well, just 2x minus 1, like that. Okay. So I don't know if this helps, but you notice that I've just got a one radical here. Now I'm going to take this and I'm going to take this. I'm going to move it all together and try to combine my like terms. And when I do that, I'm going to get, what am I going to get? I'm going to get 4x plus 5. I'm going to bring the 4 over. So I'm going to subtract 4. I'm going to bring the 2x minus 1. So minus 2x minus negative 1, which is plus 1. Okay, so all I've done is I've moved this. That's a 4. I've moved this over here, and I've moved these two things over here. And when I move these, both of these change signs. Okay, equals 4 of the square root of 2x minus 1. And if I just combine like terms here, I'm going to have 2x plus 2, right? So 2x. And then the numbers here, that's just the straight up integers, is 5 minus 4 is 1, plus 1 is 2. So there's 2x plus 2 equals 4 of 2x minus 1. Okay. Have we gotten any farther down the road? Have we kicked this can down the road at all? Well, we have, because back up here, we had 2 radicals, and that's really messy. We've got only 1 radical here. What to do next? What to do next? I mean, I could divide by 4 to get rid of this coefficient, but then I'm going to have half x plus 1 half, and that could be a little bit messy. What I think I'm going to do is, again, I'm going to square both sides to get rid of that second radical. I'm going to square both sides to get rid of this, okay? So now I've got a polynomial on the left side, 2x plus 2, so it's going to be 2x plus 2 quantity squared. Okay, I'm going to do this, and I'm going to do that, okay? 2x plus 2 quantity squared is going to be 4x squared plus 4x plus another 4x, so plus 8x plus 4, cool, equals, well, the squared is going to work on both the coefficient and on the radical, so 4 squared will be 16, and the radical squared, well, square root of 2x minus 1 times square root of 2x minus 1 is just going to be 2x minus 1, like that. And now I think you see we're working this problem. This rock is getting kicked down the road. We are making progress. No more radicals here. You can see that we're going to end up with a quadratic, which, oh, there you are, which, fingers crossed, will be factorable, which will give us nice integer roots, and then we'll be able to solve. In fact, we're going to give you integer roots in this kind of question. This is 20-1. This isn't 30-1 yet, okay? So integer roots and all that. Let's see what we got, okay? So no x squareds to combine. Plus 8x. When I go x times, or 2x times 16, I'm going to have positive 32x here. When I move it to this side of the equal sign, I'm going to have minus 32x. And I'm going to have plus 4, and I'm going to have minus 16 on the left side, on the right side, which when I bring it to the other side of the equal sign, I'm going to have plus 16. And now the right side is going to be equal to 0. 4x squared minus 24x plus 20 equals 0. Progress? Progress. We got a quadratic. We should be able to factor that. Let's simplify first. I can simplify. Because it's equal to 0, I can divide left and right side by the same factor. I'm going to divide it by 4. Because dividing by 4 is going to give me x squared minus 6x plus 5 equals 0. Remember, if I've got an equation, and I do, and I divide left and the right sides both by the same quantity, the same factor, the same constant, I'm going to change how it looks, but I'm not going to change the value. So it's a great little trick to learn how to simplify stuff. You'll be doing a lot of simplifying when you get to Math 31 calculus, because a lot of the problems you get, you simply cannot solve in the form that we're giving them to you. So you'll learn to find little tricks to simplify and to make your life easier. All right, looking at x squared minus 6x plus 5. By inspection, that is just by looking at it, I know that that turns out to be x minus 5 times x minus 1. Check it out, make sure it makes sense to you, right? X squared minus an x minus 5x, there's your 6x. Negative 5 times negative 1 is plus, okay? And so I'm running out of room on the bottom here. X is going to be equal to either 1 or 5. Yes, that's what we wanted. We were hoping for a couple of roots. And you can see how next year we might make it a little bit more difficult for you. Maybe we'll give you a quadratic that isn't factorable in integral terms, that you'll have to use a quadratic formula for. And you can imagine get some really funky rational numbers in here, or radical numbers rather, in here. And so you're going to use what you know about radicals now. It's like pumping it up a notch, right? So here we are. We got two answers. What are we going to do, right? Remember, we're looking for a solution to this. We're looking for values of x, or a value of x. Maybe there's more than one value. I don't know. We'll test it soon enough. There's definitely one. No, there isn't definitely one. Maybe this is insoluble. We don't know. Hopefully, there is at least one solution. Maybe, I guess, possibly, there could be two solutions. Who knows? I don't suspect two solutions here, because squaring factors usually, if I had x squared or something in here, squaring factors usually implies two solutions. So I'm hoping that we'll find at least one solution. It is entirely possible that there are no solutions. But why would we give you a question like that for? Let's go find our one solution. Here are the two ones, the two options we get to choose from. X could be equal to 1, or x could equal to 5. Well, let's test both of them. Let's test or verify. Let's test first x equals 1. All right, so I've had to go on to a second page here just because the way the camera is set up, you're not seeing the bottom part of it. See my handle, it disappears there. So here's what we got. Here's the story so far. We have two possible answers here. We had x minus 5 times x minus 1 equals 0, which means that x is either equal to 1 or to 5. Those are the two possible solutions. One or both, or perhaps neither of those will work. And to find out which one of those three options there are, we're going to have to test x equals 1 into the original equation, and then x equals 5. Now, it's not very likely we're going to give you an equation for which there isn't at least one correct answer from here. But the possibility is it could be 1 or 2, or in the odd case, none, right? So what we're going to do is we're going to substitute x equals 1 and then x equals 5 back into the original equation, which, if you recall, was square root of 4x plus 5 minus the square root of 2x minus 1 equals 2, okay? So we're gonna try with x equals 1. Everywhere where you see an x, we're going to put 1 and see if left side equals the right side. And we're going to try with x equals 5. So let's verify with x equals 1, shall we, to begin? Well, when we do that, we're going to get the square root of 4 times 1. Remember, where we see an x, we're going to substitute the number 1 in, right? So 4 times 1 plus 5 minus 2 times 1 minus 1 equals, and we're hoping that it equals 2. All right? So, well, what do you got? Well, 4 times 1 is 4, plus 5 is 9. Root 9 is 3, minus. And on the right side, 2 times 1, or not on the right side, but in the next part of the expression here, or the expression, 2 times 1 is 1. I'm sorry, 2 times 1 is 2. Minus 1 is 1. And lo and behold, yep, 3 minus 1 equals 2. So x equals 1 is a solution, for sure. Cool. Let's try verifying with the other option. Because, there's, well, as I said, we're going to set you up with a question that has at least one answer. It's occasionally possible that you don't have an answer. For example, remember back last year when you did factoring trinomials if you could, and sometimes you couldn't find, and you said this question is not factorable. Very occasionally we give you a question like that, but not too often. So we're going to verify now x equals 5. And all we're going to do is substitute that 5 back into the original that we had here. So we're going to get 4 times 5 plus 5 minus the square root of 2 times 5 minus 1, and see if it equals the right side, which is 2. Well, 4 times 5 is 20. 20 plus 5 is 25, and the square root of 25 is 5. Minus, all right, 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 is 3, so 5 minus 3. Hey, look at that. X equals 5 is also a solution. All right. So here's a case where both are solutions. All right. So how do you write that? Well, the solution is a set of numbers that include 1 and 5. Woohoo! But, fair student, one missing thing. Can you think about it? What are we missing? Let's look back to, yeah, you can see that here, the original equation. Got to worry about restrictions, all right? So are there going to be restrictions? Yeah, but in this case, because there's the x's, the variables are in both, under both radical signs. In other words, there's an x under two, or x's that are a part of two different radicands. We have to figure out the restriction here and the restriction here. So there's going to be two restrictions to go with. All right. So the first restriction is that, remember, we're referring back to that right there. Actually, we're going to refer back to this right there. All right. So restrictions. Well, the inside the radicand, the stuff inside the radical sign, cannot equal to a negative number. So 4x plus 5 must be greater than or equal to 0. In other words, 4x must be greater than or equal to negative 5, and x must be greater than or equal to negative 5/4. There's one of your restrictions. And I know you've lost sight of that, so I'll just scroll up. All right, let's do the other restriction now. Over here, 2x minus 1 must be greater than or equal to 0 because it can't be negative, which means that 2x must be greater than or equal to 1, which means that x must be greater than or equal to 1/2. All right. So we've got two restrictions here, but because we're dealing with the same kind of thing, that is, we're looking for numbers that values for x that don't make the original equations blow up. If you have two restrictions like this, you have to use the most restricted, or the most restrictive restriction. Is that a thing? Yes, it is. So what do you think is more restrictive? You know that the radicand cannot be a negative number. And you know that anything less than negative 5/4 will give a negative radicand, right? But you also know that there's a positive number that will also, below which, will also give you a negative radicand, and you can't have that either. So the most restrictive restriction is that second one. Yes, in one case, x can be greater than negative 5/4, but let's say it's negative 1, right? Negative 1 is greater than negative 5/4. Negative 1 won't work here. 0 won't work here. X equals 0 won't work. Only x values that are greater than 1/2 will work on both sides of the initial equation. And so the restriction is x must be greater than or equal to 1/2. Wowzers. That's a lot of work, but that's what we do here in Math 20-1. All right, go forth, do some practice questions, report back to me, let me know how you do. Cheers. Happy mathing.